Hi everyone, good evening all. Today we are going to discuss about what is the condition for symmetry and reciprocity in hybrid parameters. It's called H parameters. Okay, so coming to the condition, what is the condition? Okay, so actually H parameters are nothing but H11, H12, H21 as well as H22. Okay, so these are nothing but the H parameters of our equation. Okay, so how to write down these H parameters is nothing but, so when you check out the diagonals as well as the half diagonal values. Okay, so here the condition for reciprocity is, so the half diagonal value h12 is negative of h21 is the condition for reciprocity in the case of an h parameter. But what is the condition for symmetry? Diagonal h11 is not equal to h11 is equal to h2 is not correct. We have to find out the determinant of h is equal to 1. What is the determinant? The product of diagonal elements. The diagonal value is h11, h22 minus h12 and h21 is equal to 1. So this is the condition we need to fulfill to satisfy the condition of symmetry. Let's try to verify the same proofs. Okay, so coming to the conditions for reciprocity and symmetry, these are the condition for reciprocity and condition for symmetry. Coming to the proof, so how to write down this equation is, we have v1 i1 and at input port, at output port we have v1 i2. So we can write down v1 i2, these are nothing but dependent variables, that is equal to h11, h12, h21 as well as h22 multiplied with i1 v2. So now what is the equation of v1? V1 is equal to h11 i1 plus h12 v2 is one equation. Second equation is I2 is equal to H21 I1 plus H22 V2. So what we need to do here is, we have to compare each individual equation. Okay, let us take a two-port network and let's try to excite input port with a voltage of V1. The two-port network draws a current of I1. Okay, at output port, actually the current will flow in this direction and we need to make the current to flow in opposite direction. That's why we're writing it as minus I2. Current has to flow means I need to perform short circuit. Short circuiting means I2 is V2 equal to 0. So imply these changes. Instead of I2, you write down it as minus I2 and you make V2 is equal to 0. So in this expression, you substitute. So therefore, what we are going to get here is V1 is equal to H11 I1 plus H12 V2. So this is nothing but 0. This one modification. And the second modification here is I2, we have to write down it as minus I2. This is equal to H21 I1 plus V2 equal to 0. So now what we need to find out is the response to the excitation ratio. What is the response? I2 is the response, the excitation is V1. We have to find out the ratio of response to the excitation. Identify where is I2 and V1. So here we have I2, but here we have a disturbance of I1. So we have to express I1 in terms of either I2 or V1. So that's why we have this expression. So from this expression, I can write down I1 as V1 by H11 is equal to I1. So substitute this in this expression. So I2 is equal to H21 I1. I1 is V1 by H11. Okay, therefore, when you find out I2 by V1, I mean excitation to the response, I mean response to the excitation is H21 divided by H11 is our ultimate equation we are going to get. Second, what we have to do is take the same two port. So here we are giving the excitation. Now we will give the excitation at output port V2, and the current flows into the network as I2. And then you can see here I am taking the current which is flowing away from the network, which is minus I1. So how I1 will flow only when I short circuit this port. Okay, so the changes I have to write down it as rather than writing I1. So actually I1 flows in this direction, which is nothing but plus I1. It's our assumption. So now it is flowing to opposite to this one. So instead of I1 you have to write down it as minus I1 and make V1 is equal to 0. Then what happens is, so these are the equations we are having. In these equations, let's try to substitute. Okay, so this we are directly writing V1, and instead of I1 we have to write on it as minus H11 I1. Okay, and we have H12 V2 is one equation. Second equation, you substitute I2 is equal to H1 is there, I1 is there, you write down minus H21 I1 plus V1. I mean, it's nothing but we also have here H22 V2. Okay, so here we have two set of equations, and in this equation already I told we have to put V1 is equal to 0. So this is 0, and what we require is we require response. This is nothing but we require the ratio of response is I1, excitation is V2. So identify the equation which has I1 and V2. So this is I1 and V2. So here we are doing this under the equation V1. V1 is 0. So when V1 is 0, so here this negative will come to this side. This is H11 I1 is equal to H12 V2. We require the ratio of I1 by V2. So I1 by V2 is equal to H12 divided by H11. So from this equation we can frame out. So compare these two equations. So response to the excitation, when you compare these two equations, H1, H12 get cancelled, the minus will get here. So H12 is equal to H21 is the condition for reciprocity, in the case of H parameter model. So this is what we are getting. So now we have to verify the condition for symmetry also. The condition for symmetry in the case of H parameter model. Okay, so already I told this, the condition for reciprocity is H1, the half diagonal elements. H12 is equal to minus H21. Now let us try to do these values. Okay, so let's try to copy our basic equations. So the procedure we are employing here is we require the values of Z11. So we have V1 is equal to Z11 I1 plus Z12 I2. Okay. Next equation we have V2 is equal to Z21 I1 plus Z22 I2. So now what we are going to do here is we want Z11 value and we want Z22 value. How to get Z11 value is I will get Z11 value when this value is 0. When it will be 0 is the output port I2 is equal to 0. So therefore Z11 is equal to V1 by I1. Here I require the value of, okay, let's try to do up to here. So what is the value of V1? It's already known that this is nothing but H11 I1 plus h12 v2 divided by I1. Okay, so when you compare, divide with this value, this is h11 plus 1 h12 v2 by I1. Okay, so we require the ratio of v2 by I1. So for this, we have the next equation is I2 equation. In this equation, substitute I2 is equal to 0. Therefore, we are going to get h21 I1 plus h22 v2. You see here, we require the ratio of v2 by I1. So this equation is nothing but minus h21 I1 is equal to h22 v2. We require v2 by I1 is equal to minus h21 divided by h22 is nothing but v2 divided by I1. So substitute here. So this is nothing but h11 plus h12. What is v2 by I1? Is nothing but minus h21 divided by h22. So take the LCM, which is h11 h22 minus h12 h21 divided by h22 will be the z11. Just try to compare the z11 values. So in this equation also, we require the value of z22. How to get the value of z22? Z22 is equal to, I have to make I1 is equal to 0. When I1 is 0, then we are going to get it as V2 by I2. So substitute I1 is equal to 0 in these expressions. Okay. So when you make I1 is equal to 0, we want. So in this equation, substitute I1 is equal to 0. When you make I1 is equal to 0, this is I2 is equal to H22 V2. We require V2 by I2. This is nothing but V2 by I2. I can write down it as 1 by H22. So this value is 1 by H22. So the condition for symmetry in Z parameter model is Z11 value is equal to Z22. When you compare, denominator terms will get cancelled and we are going to get H11, H22 minus H12 and H21 is equal to 1. I can say that delta H is equal to 1 is the condition for symmetry in the case of an H parameter model. So that's already we have been proven here. So this is the condition for symmetry in the case of an H parameter model. This is the condition for symmetry in the case of an. So in the case of a symmetry, compare half diagonal elements and you have to put a negative symbol. In the case of symmetry, you have to compare diagonal elements. In these diagonal elements, H11, H22 should not write down. So you have to multiply, you have to find out delta. So all the steps what how we have solved is excitation to the response we have to find out. So excitation, sorry, response to the excitation we have to find out, and this is the units of modes. So I compared with input port and I had compared here. This is the procedure. So just by watching this video, you don't get some sufficient knowledge. You should see the procedure. Close your book. Write down the derivation. Put the heading of symmetry and reciprocity. Try to do the method what I employed here. If you have any doubt, you can take a printout and you can verify it. So this is how to verify the conditions for reciprocity and symmetry. So this is the condition for reciprocity is h12 is equal to minus h21 and symmetry is diagonal. Diagonal means h11 into h22 minus h12 equal to 0. So hope you understood all the values. If you want to compare, you can compare with the all the values. So this is all about the conditions for symmetry and reciprocity. If you're watching for the first time, please like the video and share with your friends, those who are studying in the comment domain. And if you have any doubt, let me know in comment section. And if you're watching for the first time, subscribe the channel. This is a free channel for the development of students and faculty. So if you have any doubts, let me know in comment section. So please try to work out well. Yours obediently, Ram.